let's see here. See how this goes. Alright, so that backlight is working. Nice. I need to monitor a couple of different things. Alright. Alright, everybody, bear with me. We'll give people a few minutes. Gonna work with my sponsor here for a moment. We're giving people a few minutes to join, and so far it looks like everything is okay. Oh, my kitty's here. My kitty wants some attention. Oh, oh, you need some lovin's. Oh, oh, yeah. I've not forgotten about you, darling. But you're gonna have to entertain yourself for a couple hours. Yeah. Alright, darling, come here. Oh, come here, darling. Oh, he's my good girl. Who's my good girl? Are you excited it's streaming day? I'm excited it's streaming day. We're going to teach people how to solder today. Yeah, and we've got a multimeter we're going to play with. And we got, the oscilloscope is behind the screen. We'll have to go get that before we do that. Yeah. Oh, you're my girl. Alright, you're going to have to be content with this because I'm going to put you down and ignore you for a while. Yeah. There's going to be people here. We got to tell them what's going on. Yeah. Oh, don't worry. I still love you. Alright. You're a cat. Go entertain yourself. Alright, let's see here. We got our keyboard. Let's live, and let me copy the URL because I forgot to do that. What is the URL for this one? Share, copy, close, paste. There we go. That is that. There's no questions there. We have one viewer. Yay. Alright. Alrighty. So, do we have any questions so far? No questions so far. We got our our soldering iron. We've got, what is that? Oh, that's a power supply. Yes, darling. It's just a tragic. You're going to have to entertain yourself. Oh, whatever. Is that what you're complaining about? We got a toenail here causing you trouble. There we go. How's that? Is that better? Oh, get some belly rubs. Alright, we pulled that off. Yeah. Uh-huh. Oh. There you go, darling. When she gets a little needy like that and I'm busy, I will hold her upside down because she doesn't like that as much. And she'll get the hint and go away. Alright, so I don't see any questions or comments on the chat yet. Nothing in there. But I do see a couple of viewers, so let's turn off this, get it out of the way, and let's start. So we're going to be soldering. Don't have a completed one on my desk. Oh yeah, I do. They're right down here. Oh, there we are. Let's see where my battery's at. There we go. I keep batteries on my desk just for this. I've got my little keyboard on my lap so I don't have to reach all the way across to type, which was awkward. Trying to learn from past experiences. Let's go to this view. Got some lovely artwork from my mom in the background. So we're going to be building one of these. This is the kit that we've been selling through our partner CircleCityCircuits. They are also our sponsor for the day, so if you are looking for someone to build your projects, they are a great resource. They can provide both manufacturing and engineering support, but their emphasis is on manufacturing, so if you need to make 50 or 5,000 of something, definitely want to talk to them. They're at CircleCityCircuits.com. Link in the YouTube stream as well. Some of the circuits, CircleCityCon. Yeah, some of the CircleCityCon presentations today will probably not be on the YouTube. They will probably be directly into the CircleCityCon hardware hacking village. I don't have a way of sharing everything with BSides. I believe it's San Antonio. But we're doing our best to share this stream with the generous agreement from CircleCityCon, who I'd already agreed to do this hardware hacking village for. So they have generously allowed me to share my YouTube stream with BSides San Antonio, so they'll get all of my content. The other stuff is probably going to be limited to the voice Discord chat on the CircleCityCon conference, just because that's how the logistics broke down. Because I cannot afford my own Zoom account to bridge everyone in on, and I think it's just going to be simple to let them do their presentations that way. Let's see here. Let's take a quick look at the schedule, which is not fully filled out. Apologies, but we do have a bunch of stuff in there. So right now we're doing the welcome remarks and the first through-hole soldering class / demo, which I'll be doing here after our introduction. Then at around 11, we're going to have a presentation on basics of electrical components like resistors, capacitors, and such. We're going to have a break for lunch from noon to 1 Eastern time, and then we're going to have a wonderful presentation on the Arduino dice simulator in Tinkercad, I believe. That's you don't want to miss that one if you're at all interested in learning how to mess with Arduino, especially if you don't want to buy the hardware, if you want to figure out how to do it online. It's a wonderful tool. Then I'll be showing off how to use a multimeter and oscilloscope, and then after that we're winging it. We hopefully will have a third presenter, but they had a lightning strike, and a lot of their technology fell victim to that, so I don't know if they're going to be up and running in time for today or not. I have not heard a affirmative on that, so I'm going to be pessimistic on it. Alright, that's all done. Let's check for questions. I don't see any questions on the YouTube chat, and I don't see any questions in the hardware hacking chat, and I haven't heard anyone chime in the hardware hacking voice chat for CircleCityCon. The B-Sides San Antonio folks are going to have to chat on the YouTube. I will do my best to check everything as I can, but you know, it's going to be up and down, up and down. So I'll go back and forth. Alright, well, let's get started with the soldering demo, shall we? Switch to this view. Alright, so we're going to be making one of these. I'm using an old kit from DerbyCon that I happen to have a ton of extras on. But if you purchased one from Cyber City Circuits, our sponsor and partner in this, you will have one with the Mr. Blinky Bling logo on there, which is nice. Oh, excellent. I've got a comment on the hardware hacking chat for CircleCityCon saying that there are no questions. Excellent. Alright, so we're going to be building this. It is basically an LED flashlight. We have 8 bright LEDs. We have 1 current limiting resistor. And we have a battery pack. It is very simple to build, and it's designed specifically for beginners. It has a bunch of beginner-friendly features, and let's take a look here. Oh, we are out of focus. There we go. Including these nice long pads where we're going to be doing our actual soldering. Now, typical pads are going to be smaller, more like this. But for beginners, we like to give them a nice large area to work with so that they can better see what they're doing and jump right in. I will give you an example of a more typical kit PCB while we're here. So here we go. You can see these are more typical size holes. So this is what you'll be working with in future kits, but we like to start people with these nice big ones. These have a couple of advantages, one of which is that by their shape they pull solder out to each side, and that helps prevent bridging. But I'm getting a little bit ahead of myself, so why don't I come back here? Let's talk about soldering. Soldering is not like other forms of sticking things together. It's not like tape or glue where using a lot of pressure is your friend. And in fact, if you use a lot of pressure, you're going to have a bad time in a number of ways. You might damage your soldering iron, you might damage your project, but you are going to find it a frustrating experience. Instead, we're going to be using our soldering iron to apply heat. So, naturally, all of the metal bits are going to get very hot and you don't want to touch them. The heat is going to be out here at the end. I don't have this one on, obviously, or I'd be saying some uncouth words after touching it. But the heat is going to be focused in the tip, but all of the metal bits will still burn the absolute crap out of you, so you do not want to touch them. You want to hold it more or less like a pencil or however is comfortable, because you're going to be laying it on the work. You're not going to be pressing it into the work. You don't need to stab the work. We just want to lay it on there and just kind of like guide it into place. So that is the approach we're going to be taking. So we're going to be basically using this heat to melt solder, which is a metal alloy. and we're going to use that to generate a electrical and mechanical bond. It's going to both glue it in place and conduct electricity. So when we're doing this work, we need to pay careful attention to how the solder is applied so that it does both jobs equally well. If it holds it in place mechanically but isn't providing a good electrical connection, then it's not going to work. If we have enough there to provide an electrical connection but not enough to hold it in place firmly, then it may snap off or break loose during heat cycling or vibration or whatever. So we need to keep that in mind. Alright. Let's take a look at how we're going to do this. And I forgot to adjust my scaling on this. There we go. I upped the resolution from the Twitch stream to the YouTube stream. Alright. So, when we're making these connections, we want to have a nice firm I need to turn the sponsorship overlay back on, and let's move that down. Oh, I thought I had done all this, sorry. And this one should be over here. There we go. So we're going to be forming an electromechanical bond. We need to fill this whole pad up. We need to make sure that we don't just solder on the top of the leg here. If we do, it may hold itself in place, but it may not conduct electricity down here. We need to make sure that we have a nice, good connection without connecting these two together, because electricity is like water. It's going to take the shortest route. We need to make it do the work to go through the diode. Most of these are going to look like this, though. And on this side, nope, there you go. We're going to see a positive and a negative, a square and a round hole. And we're going to have these LEDs, which look like this. And you might be wondering which leg is the positive and which leg is the negative. And that is pretty simple. The one with the long leg is positive and the one with the short leg is negative. And to make this kit super easy, even for kids, we've added a short leg and a long leg indicator. So you just take the long leg, put it in the long leg one, and the short leg goes in the short leg one. Like so. Let's see here. There we go. And then we want to bend the legs out like this. We want to bend them in line with these because we're looking for a strong mechanical bond. So out to the side here, we don't have as much. Now on a smaller hole like this, it's not going to matter. But for these, it's just good practice to get used to doing them in line like this. So let's switch back here. So we're going to go ahead and put all of our diodes in. Now diodes are like turnstiles for electricity. They only let it go in one direction, and that's why we have the positive and the negative legs. We want to put all of them in first, because what's going to happen is we're going to end up with a nice little table where the LEDs are the legs and this PCB sits up off your table, and that will keep the PCB from getting too warm and damaging your table. Let me rearrange a couple of things here. Alright, so I'm bending a couple of my legs. Let's go here. So you can see I've bent them out a little bit. Actually, let's go to this camera. This will be the better camera. There it is. So here you can see we've got all of our legs sideways. I've bent these just so the legs don't go all the way across. It's no big deal. And you can see it forms a nice table. We have a nice gap. I can put my tweezers all the way in there. And that air gap is going to protect your table or whatever work surface you're soldering on. Some amount of engineering has gone into this, I promise. Alright, let's zoom in. Alrighty. Which ones are we looking at? We're looking up here. Okay. This camera's a little upside down, so bear with me as I check for messages real quick. Alright, that's all done. Let me check for questions. I don't see any questions over there. Alrighty, several people are having trouble finding the village channels. Alright, so village channels did not show up for our sponsor till they went and asked registration for that, so you might need to ping registration. Oh, and there is a message on our YouTube for that. Excellent. Alright, so that's taken care of. Alright, so let's talk about soldering. We're going to be applying heat. And when we do that, we need to think about how heat flows. If we use the soldering iron straight up and down like this, we're not going to be conducting much heat because there's not a lot of surface area. But if we come in sideways like this, we're going to have a lot more surface area and we're going to conduct more heat. That said, if we use a dry iron, and this is, let me turn it on. There we go. This is currently a dry iron. Alright, no questions there. Let me clean this off so we get up to temperature. Alright, so here we have a dry iron. And actually, let's switch to the ultra close-up view for this. Alright, so here is a dry iron. And here is the tip that even people who've been soldering before generally get from this class. This dry iron is not going to conduct heat very well. It's forming a layer of oxides, which you can see as it gradually darkens. Those oxides are insulating, and they are going to affect the surface tension of the liquid solder that is present. It's not going to want to incorporate, and therefore you're going to have a bad time. It's just rough. So what we want to do is wipe it off in the brass. We use the brass more than the wet sponge because a wet sponge pulls heat out because it converts water to steam. So now it's nice and shiny again. It's still not going to conduct heat very efficiently, so let's talk about tinning the iron. So if we were pretending that we're going to solder this this bottle to my hand, let's turn this sideways, and we bring the iron in at an angle like this so we have more surface area instead of at instead of the tip, which doesn't have much surface area. We bring it in like that, which we can still see there's a nice little triangle there, right down here, of empty air. And air is a really good insulator. It's not going to conduct heat very well. So what we want to do is fill that little triangle up with a little bit of solder. And that's called tinning the iron. It is, however, super easy to overdo this. And if you have too much, it's going to be a problem. So let's talk about why that is. If you have the right amount of tin on your iron, when you put it down, the surface tension of that liquid is going to be such that it pulls itself across and creates a nice little thermal bridge exactly where we want the heat. But if you have too much, it's going to ball up, and when you press it, it's just going to sit on top like a balloon instead of flowing down and creating a heat. And there's going to be a really thin layer of oxides and air between it and the thing you're trying to heat up. And that thin layer of oxides and air is going to prevent the heat from going exactly where we want it, and it's going to radiate out just everywhere, all willy-nilly, instead of exactly where we need it. And that's going to cause a lot of frustration. This has caught a lot of people off guard. One of the stories I like to tell, with his permission, is a good friend of mine who'd been soldering for years, was sitting down, borrowing one of our stations, doing some soldering while I was teaching a new person on my end of the table, and he hears me go over that, and I hear, been doing this wrong for 16 years. This is way easier. I don't have to use so much flux anymore. There's very much a Goldilocks amount of tinning. So let's take a look at that in our close-up. So we're going to clean the iron off because it's been sitting there oxidizing. There is the dry iron. This is a good amount of tinning. This is still a good amount of tinning. This is too much. You can see it's not a big difference. This is way too much, and this is what you frequently will see people do. They'll put a huge ball of solder on there, but watch what happens when we put that down. Let's get this on camera. There we go. We put that down. It just sits there as I described. It's just sitting there. When we pull it up, we have this connection here where it's stuck a little bit to the leg. But look, there's no mechanical connection, and it's this ugly, jagged, gross connection. Not at all what we want. So let's switch to a fresh one, and let's do the correct tinning and watch what happens. And this is so cool, y'all. We put that down, and you see how it's pulled itself across. We now have a nice little thermal bridge, and then we're going to put the solder on the other side, make it work to get to the heat, and it just melts right on in there, pulls across the part over to the heat, and then boom, beautiful shiny silver solder ball. It needs to be shiny like this. If it's not, if it's wrinkled or gray or dingy looking, it's called a cold joint, and it does not work. So let's do that again. We just put the right amount of tinning. You see how it pulls itself across? Then we just add a little bit of solder to the other side. Then we leave the heat on there just an extra second to heat it all the way through, and look at that beautiful silver solder ball. So let's come back over here and see if we can't fix this one. We put that in there, and a little bit of solder, and presto. But now we have too much tinning on the iron, and we need to wipe it off. Start over. Come down here. See how it pulls itself across? Just like that. Then when you see that, you can add the solder to the other side. There we go. Come on now. There we go. Then a little bit of extra heat. Just like that. Alright, so let's take a slightly wider view. Let's see here. We're on this side. Alright, yeah. And we'll take a look at how this is done on a slightly wider view. You don't have to retin all the time if you have the right amount of tinning on there when you're done. Heat on one side, solder on the other. Heat on one side, solder on the other. Just like that. Let's go this way. There we go. We'll do these two as well. So let's screw a couple up and see how to fix them. We'll come down to this one here. Make sure I have it on the camera. And let's do a crap cold solder joint there. Over here, let's bridge it. There we go. And then over here, let's see if we can't create a really ugly one. There we go. Alright, so now we have several bad examples. We have some mistakes. Let's switch to our close-up and let's take a closer look at them. So here we can see we have a cold joint. It's wrinkly, it's gray, it's not covering the whole pad, and it's generally pretty ugly. This might work, and it might work for a while. It might not. It's not safe to leave it that way. Same thing over here. What we have are these different lumps, these spikies, and what this means, very simply, is that as the liquid has cooled and done that phase transition into a solid, it has done so unevenly, and so there are going to be fracture lines throughout this where it cooled unevenly, and this is not going to work very well. Fortunately, the solution for both of these is really easy. What we're going to do is we're going to take some fresh solder and some heat. So we're just going to heat this all the way up. You can see how it's melted down, and we're just going to put a little bit of fresh solder in there because that's going to give us a little bit of flux core solder. And then what I want to do, and I'm going to pull this a little bit over to the side so we can see, we have a little bit of extra solder, so I'm just going to draw along like this. And there we go. Now, when we come back with our edge cutters later, and we always want to hold on to this with our hand, just like this, we can come back and trim this, and no one will ever know. It'll be our little secret. Same thing over here. We're just going to take a lot of heat, melt that back down, and I don't think we even need anything other than just a lot of heat. Now we have a beautiful solder joint. Over here, we have that nasty bridge. This is not going to work. We also have some phase transition lines we can see here, where it's not evenly heated all the way through. But the electricity is going to skip right through here and ignore our LED entirely. So what we're going to do is we're going to take a dry iron, and we're going to take the fat part of the dry iron, and we're just going to let it sink in here, and we're going to draw perpendicular like that. And look at all this solder that's pulled off onto the heat, because that's where it wants to live. We're just going to wipe that down, and we're going to come back over here and do the same thing I mentioned before. Let me rotate this a little bit, and we're just going to pull along. Look at that. Now we've pulled all that excess solder onto the leg that we're going to trim off anyway, and onto the iron. And look at that, presto. No one will ever know that that was messed up. Let's do a couple more. Just as, let's see here, I'm going to see if there are any questions real quick. Alrighty. Alrighty, I'm not seeing any questions. Alright, so let's do a couple more real quick, and where are we on time? Alright, good. 15 minutes to the next presentation. Got plenty of time still. So I'm going to do just, oh, I'm on the wrong one. There we go. There we go. You can see that we've got a little bit of liquid solder down there. You can see it flowing around as I move. That's going to just pull this in over to the heat, no problem. Look at that, just perfect. That tinning comes right down. Now we have to make sure we're touching both the part and the pad, otherwise we're not going to end up with solder on both. It's only going to stick to the hot one. I want to straighten this up a little bit. There we go. So I started this one, but I was off camera. Soldering's a lot of fun. It's very relaxing. And when you're done, you have a sense of accomplishment because you've built something. Alright, so let's switch to a slightly wider view and let's talk about trimming things. We have edge cutters here. They have a flat side. And they have the angled side. We're going to take the flat side towards the part that we're cutting. I'm going to hold this with my fingers. Yeah, I'll put this on camera. I'm going to take the flat side down. That camera does not update as fast. It's over the wireless, sorry. And then we're going to trim. And we want to make sure that there's nothing here to catch on our skin or clothes. So we have to turn it around for this one. So again, the flat side toward the ball. We do not want to cut the whole ball off. We don't want to come in and try to trim all the way down to the PCB. That would be counterproductive. We want to leave the ball there. We just want to hold this in place and trim as close as we can so there's nothing to catch on our skin or clothes. And that's really all there is to it for all of these. I'm just going to do the same thing. Hold that. Make sure, no, didn't quite get enough, so I'm going to come back and trim a little bit closer. There we go. Yeah, make sure you all can see this as we do it. Gotta hold it with our fingers. On these on the PCB, we just hold it down with one finger like that. And that works just great. Then you want to throw these in the trash immediately. If they get stuck in your carpet or on your floor, they make for a really, really bad sliver. They jab you real good. It's not fun, I promise. Ask me how I know. Alrighty. Get all this trimmed up. It'll be time to do our resistor. Now the resistor is going to go in with a more normal connection. A resistor is being used here to moderate the amount of energy that is going through the LEDs from the batteries. This is done both to preserve the batteries and the LEDs. If too much current is going through the batteries to the LEDs, the LEDs can be damaged, which is not good. Oh, come now. There we go. And it can also damage certain types of batteries if you discharge them too rapidly. So, oh yeah, I should probably put that back on camera. Let's go here. So we have our kit. We're going to put the resistor in along the resistor line. like such. Doesn't have to be perfect, and unlike the diode, it does not have a positive or negative. There's no anode or cathode here. You don't need to worry about that. You just need to put it in. That said, this one has been done with the resistance, not the resistance, the precision band, which is usually gold or silver, on this side. So right here on the right side. Now we have this bent out here, and we're going to do the same thing we did before. I'll show on the wide view here, and then we'll zoom in and take another close look. I'm just going to line up the heat on one side, touching both the part and the pad, then touch the solder to the other side. We need a little less this time, but we still want to have a nice shiny silver solder ball. Let's move it over here, go to our soldering, only super zoom, there we go. You can see a little bit of tinning, there we go. See how it pulls itself down. There we go, you can see that it's kind of formed a nice little bridge. It's sticking there. You can kind of see it wiggling back and forth. Well, when we put that solder in there, it's going to conduct that heat exactly where we want it. We're going to have this lovely shiny silver solder ball, just like that. Then we're going to hold this with our finger, take the flat side of the cutters against the ball, and look at that. Nothing to catch on our skin or clothes. We can pull our finger across there, no problem. Same thing on this side. Turn it so that I can actually get to it. There we go. Hold that down and pop that off. Now it's time to do a test. Is it working? The way we're going to test this is we're going to load the batteries into the battery pack, looking at the directions on the battery pack. We're going to hold it up, and then we're going to put the battery pack in and make sure that all 8 LEDs are lighting up. And as you can see, they are. So we're going to remove the battery pack. We're going to remove the batteries. Several batteries do not like a lot of heat. Most batteries do not like a lot of heat. There are a couple of types of batteries that do, but you're not likely to find them in a project like this. So, yeah, we want to avoid conducting any heat into them. We're going to put it in the back, and then we're going to flip it over so it sits like this. Yeah, we're gonna put it in like this. Then we're gonna flip it over like this so we have our 2 thick pegs sticking out, and then we're just going to solder those. A little bit of tinning, a little bit of solder, a little bit of time. Presto. Oh, that was hidden behind the LED. I'll tell you what, let's go back to our close-up. And there we go. Let's watch it here. Let's change the focus a little bit. There we go. So we have our tinning comes across. You can see it's formed a little bridge. See that stickiness there? That means we can put our solder in there, and look at that. Just a little extra heat on there. Just always leave the heat on there a little bit longer. You don't want to pull the heat and the solder away at the same time. You want to leave that heat there. You want to put the heat on first, then we add the solder, then we remove the solder, and we leave that heat on there for just an extra heartbeat or two, just to make sure that we've fully heated it all the way through. Then you pull it off. It's better safe than sorry. We'll come back over here, and we're going to trim these. These you definitely want to keep a finger on. They leave, they're nice and thick, so there's a lot of energy when you trim them. And they have been known to leave the kits with some authority. Alrighty. And now we have a working kit. If you have a hot glue gun at home, I highly recommend that you hot glue this side of the battery. One of my favorite parts of doing this in person is that I get to run the hot glue gun. which is absolutely fun. If you've never hot glued something together, I recommend it. It is a lot of fun. Alright, so we have about 5 minutes left for our next session. The next session is unfortunately going to be exclusive to CircleCityCon. It's going to be in the voice channel with a video presentation through that, I believe, unless the presenter wants to get with me for my YouTube stream, in which case we'll be back here. Anyway, I appreciate everyone for coming. I hope you had, let me double check, there are no new questions. I don't see any new questions. Yeah, I appreciate you for being here. Thank you very much. I want to thank our sponsor, CyberCityCircus.com. Good group of folks. Happy to say I've been friends with them for a while now, and have had nothing but wonderful interactions with them so far. They are your premier, U.S.-based PCB assembly house. So if you need your PCBs assembled, you've got a project, you want to build a badge for your conference, you want to do something for your work, whatever, you need 50 or 5,000 of them or whatever, please give them a look. They've got a bunch of equipment and gear and all sorts of pick and place machines and inspection tools and solder mask tools. But really some cool technology. Kind of jealous, want some of that myself, but can't afford it. And don't want to run it as a business, to be honest. It's just too much headache. So good on them for doing that. But we do appreciate them very much for supporting what we do here at the various hardware hacking villages. This is, I think, their third time sponsoring us. So big thanks to them for that. I want to give a big shout out to all of my volunteers. We've got scroll up to where the names are because I cannot remember names. We've got Chris, who goes by TechGirlMN on Twitter. Who's going to be teaching Tinkercad and the Arduino workshop, which is coming up. We've got Mix Edna, who's going to be doing the one that's coming up next, I believe, which is resistors, capacitors, and electronic components. So you can learn more about the components. That's why I didn't talk about it too much in the soldering demo. We've got a whole workshop on that. And hopefully, if we hear from Red, if he's got his technology going, he will hopefully be here later to talk about how to read a data sheet and build more complex projects than you'd think. Just copying and pasting from data sheets and using a tool like KiCad, which is a free PCB layout tool, to replicate those circuits and then lay them out on circuit boards. You can get a lot further than you'd think just copying the reference circuits and then throwing your own code on the microcontroller. I appreciate you all for being here, and I will shut down now for our next speaker.